Alrighty. Oh, that's good. Let's see if this is all up and running. Copy. YouTube is making me watch a advertisement on my own stream. Oh, great. All right. Let me see if the sound works. Sound works. All right. Lovely half a minute of delay again, as usual. All right. I'm going to assume that the sound will keep working. So you guys let me know if that goes wrong or not. Hello, Ben Stanley. How are you? Nice to join. Of you to join. Hello, Unleavened Eagle. All right. We're up and running. Okay, let's just make sure we mention it on Twitter as well. Let me have a look. Where is my profile? Oh. There we go. Okey-dokey. Very cool. Welcome, everyone. All right. We'll give it a few more minutes to see who joins into the stream. Might have a little bit of a look of what has changed since my last stream. Of course, you know, last week we started this little project. At that point, I still named my stream the Unplanned stream, or whatever I gave it for a name. Hi, Lucia Honda. How to play with an Android phone. Hi, Rodzilla. Android phone. That is not something that we will go into tonight because I'm doing a lot of VR stuff. That's what my channel is all about. I do have an Android phone here, which I use for some AR code stuff, which I really need to get back into. But in a nutshell, if you want to do something on an Android phone, you have to go to export and you have to add an Android template and then go through a number of setup steps. You have to install Android Studio as well because it piggybacks on that. And then you connect your phone and then you can push out a Godot application to your phone and you can test it on your phone. But as we're looking at our space project tonight, that is what our intention is all on tonight. So yeah, last stream we made a start on this project. At that point in time, it was just a little bit of a toy. Still is, really. But I've decided to do this as a regular thing. Just every Friday night, I plan to work on this project a little bit and see how far we can take it and what we can do with it. We'll see what comes of it. At this point in time, it could just be nothing. It could be something. We'll see. But it's a lot of fun. I had a lot of fun with it, and I did spend a little bit of time during the week polishing up the work that we've done so far, just trying out a few things, and we're just going to continue on that work tonight. So yeah, that's the plan for this stream. How to play without Oculus. You mean without an Oculus Quest? The only option that you have right now for VR, Godot Docs, mobile VR. Why does it never find the one that I'm looking for? There we go. is you can use this mobile VR interface instead of using the Oculus plugin or the OpenVR plugin. And that gives you a stereoscopic view of your scene on your phone, and then you can insert into one of those HMD holders, and you can work with that. This is something that does need to be perfected a little bit. It works as far as the rendering is concerned. You've got a number of values that you need to tweak and set to match the size of your phone and match the size of your HMD container, whether you're using a cardboard container or whether you're using a Gear VR or something like that. The biggest problem that we still need to look into is that the logic that takes the sensor data from your phone, so your gyro and your what's the thing called, the gravity sensor, that is currently updating at a too low frame rate. So it lags, and there are settings you can change. You can do a custom build of Godot. There's a I think there's a PR out there that shows you how to do it. That sets the update speed to very fast, and if you have an Android phone that can keep up with that, then it's pretty smooth. It works really well. But that's your only option on Android at the moment if you're not using something like an Oculus Go or an Oculus Quest. Do I like or dislike the new GitHub layout? I have to be honest that I haven't really been paying attention to the changes. Most of my interaction with Git is actually through the command line, so I really only get in here when I need to look at PRs and issues, and I haven't really noticed that much change. So I'm not quite sure what changes have been done that really get in the way or change your productivity. I haven't really played around with it that much, to be honest. Yeah, so there's that. All right, so let's get back into our little project, and we can see that quite a lot of things have changed. I'm playing around with a little planet in the background. That planet is linked up to our to the position of our player, so it seems to be fixed in space, so that it isn't like, a very tiny little planet that you can get around. You can actually never reach it. But I'm still playing around with how we display that. We have a nice little sky in there right now, and for that I actually found this really cool website, which is www.tyro.github.io, who has this nice little generator, and it just it takes a randomized value, and you can keep changing it until you get something that you like, and it generates this really cool star field for you. So and then you export that to a file, and you can use that, which is what I did. Sorry, my chair is a little squeaky. So yeah, I exported that at a high resolution, and got a beautiful little sky. For the planet as well, by the way, I found this thing called Textures for Planets. I've still got it open. So it's this little tool that just generates a texture for a planet, which is exactly what we want for these sort of things. So that's some pretty cool tools that you can find online. So that's two things that I've changed. So we got our little background going right now, which is a lot better than our black background that we had before. I also spend a little bit of time. I think I just moved something by accident. Did I just change something back? I just changed something back. That wasn't smart. So yeah, I'd spend some time texturing and coloring our carrier that we're displaying here. So this is like I said last week, this is a carrier that I downloaded, bought it off CG Trader. While it had some default color set, it didn't have any textures or anything like that. So I played around just with giving it some metal textures, and yeah, just dressing it up a little bit so that it looks a little bit nicer. But the main work, of course, is our interceptor, which is currently still only the cockpit. But I did spend some time making sure that all the displays are there. And I added in our controls. And the other thing, which turned out to be a bug in Godot, was that from my joystick. So I hope that actually shows up in my camera, because I'm using this automatic background removal tool. So I hope that the joystick pops up. But the little slider here wasn't being picked up by Godot, because it was actually not implemented on the Windows side of life. So I put a fix through this week, and that PR has been accepted. So if you build from master, you have now got a version of Godot that will pick up the throttle on these types of joysticks. I rejigged as a result our scripts a little bit as well. So our plain script before had all the logic of the input in there. I'm now loading a script that I have set into my auto load, and that is a script where I can request all the joysticks inputs from, and that does all the sanitization of the joystick inputs. And all that I'm doing here is apply my my inputs to my spaceship. So we now have our central impulse reacting to our throttle position. We have our roll, pitch, and yaw all applied just like we did last week. But they're now coming from this script where I'm actually loading the joystick values. And the reason I did that in a autoload script is so that we can tie this into some configuration. So later on, we'll build a nice interface where a player can configure which inputs to use for all these different things, because all the joysticks that are on the market, they're all different. And especially when you start looking at the more high-end things where you have your separate HOTAS and you've got your pedals on the floor, they will come in as different joysticks, which is also the reason why I've got the joystick ID repeated for every axis. Might be that one joystick is used for the rudder controls and another joystick is used for the ailerons and that sort of stuff. So that is something that we'll eventually add an interface for. Or, you know, if someone uses a gamepad, they might want to remap the analog controls on the gamepad. So that's something that will come. Hi, Union Bytes. How are you going tonight? So that is why I moved that into an autoload script. So we have all that logic all centralized. The other thing that I may add in at some point in time is keyboard overrides. So that you can actually control the flight with your keyboard. And especially when we're looking at inputs like presets and that sort of thing, that could be really nice. I don't believe the keyboard is very usable when we are working in VR. Because you can't see the keyboard. You've got your VR headset on. You can feel or you know whereabouts your joystick is. So once you put your hand on the joystick, you can play. But a keyboard, you can't really see what you're typing in. So I think that the keyboard as an input device for a VR game is questionable at best. But we may put that overall in at some point in time. We might even at some point in time change the game that you can switch between VR mode and just desktop mode. Although personally, I believe that once you play this type of game in VR, you don't really want to go back. This is one of the areas where if you love this sort of game, you really, you do really enjoy the VR aspect of it, because you can look around and especially when there's enemy ships floating around or flying around, you can really track them. In a desktop game, you are looking forward. So if the ship's coming from the side, you can see it on your radar, but you have to maneuver your ship in order to see the enemy. While if you can actually look to the right, or you can look to the left, or wherever the enemy ship is, you can see it, and then you can move your ship towards where the enemy is. It just feels so much more natural. It really is. It's a game changer for this type of games, if you ask me. And that's also the thing that you read online. People who have played things like Ace Combat were very disappointed that it only had a few missions with VR support, not the whole game. Yet the VR missions are the most fun to play because of the interaction that you have, and that's even on a PlayStation. So yeah. Anyway, let's see if everything is still working or if I screwed up something before we went. Now, again, I am using the software that removes the background right now. So I don't know if you can currently see me holding the headset. When I was testing it out, it kept disappearing on me. So if my face suddenly disappears, you know that's why. But we'll see how well that works. I'm also going to go and maximize that. There we go. And let's push the button to center our thing. That's another thing that we're going to be working on tonight. Make sure that we know that we have to center our display after moving. I do need to move my microphone out of the way because I knocked it with my head. I hope that didn't make a really weird noise. But yeah, let's see. Where's my... There we go. All right, let's go flying. Oh, my tracking suddenly went gone. No, I crashed. Why did I crash? No, I'm back. What happened there? So for some reason my OpenVR had a bit of a hiccup. So there we can see our moon. We can see our carrier in the background there. Now, as you can see, I can keep flying towards the moon. It will never get any closer. It's just there. But we should be able to go back to our carrier if we see it. I also applied a little bit more drag onto our plane, so that it's a little bit more arcadey and not too overly realistic. Because, like I said before, it's like playing Asteroids in this thing when you do a proper physical implementation of the flight model. But yeah, it means that we can kind of fly. And oh, I am well, my collision shape is too high, which is why we are currently going through the roof. So we need to make that collision shape a little bit higher, a little bit larger. Although this is one of the reasons why I actually don't like to use this carrier as our carrier model, because you know, this flying inside and out of the carrier is well, it's fun to do, but it is very tricky, and it doesn't really add to the sort of gameplay that we're going for. So I might eventually end up going for a different carrier where we just get launched out of a launch tube. But for now, you know, it does the job. So yeah, we're able to fly pretty naturally around our carrier. And yeah, it's pretty neat. So, all right. The next thing that I want to do is I actually want to start using our controls that we see here. We see our throttle control on the left and our joystick on the right. I actually want those to start reacting on our actual throttle input. So that's the next little bit that we're going to build on this project. There we go. All right. Yeah, I use the xsplit fake green screen thingy, which I started using because I do have a green screen behind me, which is currently actually using. I'm actually using it to block out a big mirror that I've got behind me, or else my lighthouse tracking starts screwing up. The problem that I have is that if I put my green screen properly behind me, my lighthouses get blocked by the green screen. So that is why I am trying out xsplit to do the background removal and you see how it works. And for the most part, because the actual background that you see is fake, it's just a photo. You don't want to see my room right now. It's very messy. So yeah, so I'm just using that just to test with it. But yeah, I'm gonna be interesting to see when I watch my own stream back, to see how well xsplit removed the or if it handled the headset properly. Because when I was testing before, I had a big hole in my head, which was funny. So you guys may have gotten that laugh just now. I don't know. So, Union Bytes, yeah, I'd love to have some asteroids if you have them. I have one for in a minute because I want to do something with asteroids in a minute. But I'm not even sure if I'm supposed to be using that because I downloaded that one from Free3D, which is a site that has sort of, for me, pretty unclear license requirements. So I think it's fine for doing a tutorial and stuff like that where I've used it before. But the moment that you include these models in your like a commercial product or something like that, things change, and it's not always very clear with them. With CG Trader, it's very clear, which is why I've bought the carrier, and I've bought the inside of the interceptor, even though those are just stand-in. Excuse me. Even those are just stand-in models. Obviously, if I go down this path and we keep building this out, and this actually becomes something more full-fledged, I do want to start either finding someone to make what you call it, to make assets for me, or just buy other assets. I'm not sure. We'll see. Or maybe even find someone who I can work with. We will see. That's much further down the line. Hello, Andre. How are you? Alrighty. So we want to go and move our. Actually, let's start with our throttle. Make our throttle move. So I've already set it up. So throttle is this one with a spatial that acts as a gimbal, so that our mesh itself is actually offset, and that makes it nice and easy. Keep selecting the wrong one because we simply move our Z rotation. As you can see, it's going up and down. So it's standard, it's 0. And you can see that pretty much full throttle is minus 90 degrees. So we're just going to be switching it between 0 and minus 90, which is exactly what we need. Our script, our input script, already makes sure that our thrust... No, it doesn't. That's interesting. I thought I had made that react to it. Let me see. Did I leave that here? I left that here. So our thrust is being adjusted in here. I'm going to move that. I don't want that over here. I actually want that in our input script. So let's move that over here and say, and we're doing that before the keyboard input. We're going to change our range to 0 to 1 so that we always know that from our input we get 0 for no throttle, 1 for full throttle. Hey Game Endeavor, how you going? So yeah, I haven't implemented backwards. I played around with that, but I actually found that too confusing because I wanted to be able to put my throttle control on my joystick all the way down, know where it stops, especially because I can't see the joystick itself when I've got my headset on, so I need to kind of feel it. Someone's smashing doors. I hope you guys can't hear that. So yeah, so that's why I didn't want a back on there, because else you really have to figure out where the 0 point is, where the I don't want to move point is. Obviously, with our joystick, we're in space, so we can turn around any axis, even if we're standing still. So we can turn the ship around if that's what we want to do. Maybe at some point we'll implement the reverse. I don't know. It might become a button that you can do a reverse push. The other thing that I've been thinking about is using the hat on the joystick to do that sort of thing with. So our input script will now return 0. Hold on, I'm just filling up my glass of water. Always dangerous to have around this stuff, so I'm moving that quite far away from my computer. That wrong one time. So we know that our get thrust will return a value between 0 and 1. Now we could implement our movement right here in our physics process, or we just put it in our process itself. I guess it can't really hurt just doing it in our physics process. I think that will probably do just fine. Let's go and zoom that out a bit so we can see what we do. Also position handle. So that simply becomes cockpit throttle dot rotation. Let's just do rotation degrees. And that simply becomes current throttle times minus 90. And that should result in our throttle moving with our inputs. Let's have a look if we did that right. We did. Full throttle, half throttle, stop throttle. So yeah, we can now see how fast we're going. Alrighty. Okie doke. So now with our joystick position, it gets a little bit more tricky. Because we have all our values to take care of, but the principle is the same. So let's just see what happens if we do each one at a time. The biggest problem that we have with these is what is called Gimbal Lock, where we apply. Well, we won't actually get into Gimbal Lock because we don't move our joystick far enough, but because when we move the joystick in a certain direction, the other axis will stop working properly. So we might need to do that a little bit more smart. Let's just see. So roll was left right, so let's just start with that one. And we're not going to do that if 0, because if it's 0, we actually want that one to update. So that's this time our flight stick that we're going to be moving. And in this case, I'm actually going to... Do I want to use the rotate function on that? That's a good question. Or, well, let's just first see if we actually can go... in this case, I'm just going to change the rotation itself. So rotation degrees will express our rotation in actual degrees. There's an extra conversion that is taking place from radians to degrees there. I think in this case it's worth it because it's easier to read what we're doing. But when we do these sort of things, I kind of like playing around with just the radians and just apply a factor, because the radians, when we're working with values between -1 and 1, now radians, of course, halfway around the circle is pi, full way around the circle is 2 pi. So when you look at a circle going from halfway from here to here, so that will be a distance of pi, 3.2 or 3.1415, etc., etc. Then 1 is just about a third of that, just a little less than a third, and that's really a nice distance of travel for what we're doing here. We might extend it a little bit, but then it becomes really easy. You just multiply it with a small factor, so with 1.5 or 1.2 or something like that, and you just use a value that seems to work well. It doesn't have to completely be precise. We might be rotating around the wrong axis. I think this is X that we need to rotate around, or is X for pitch? No, roll needs to go around the Z axis. So let's go and do it like this. And I just want to test one axis first. I'm actually going to leave my no, I can't. I actually need to track that because else we can't see what we're doing. Come on, find my headset. There we go. And we're just going to go do this. And so we didn't do that one. We did this one. And we're going definitely around the wrong axis. But we can see that's actually way too much. So yeah, I'm actually going left to right instead of from back. So maybe the X was correct. But the problem that we have is that when we start doing the other axes, we're going to get into trouble. So that's right. Did I? Ah, okay. Helps if I edit the right field. Sorry about that. Let's go and edit that one. There we go. All right. And now that we know that that is Z, let's actually remove that empty space, or empty line there. So this is going to actually be our Z, and we're going to go and do pitch. Learn to spell bass. There we go. All right, let's try that again. Hopefully this time we've got the right axes, but I think we're going to see a problem now. And let's center our display again. There we go. Okay, so forward and backwards, that works. Left, right. That's not too bad. Obviously, I want to make it less. I'm actually not too unhappy about that. It looks like it's doing that in the right order. So let's see if our Z is going to mess things up. But definitely one of the things that I want to do is we're going to go and make that a little less extreme. Go away, little thing. Kido. Let's see, and that becomes Y, and that becomes Yo. There we go. All right. You might get lucky with this and not have the axes clash with each other. That would be really nice if that was the case. All right. That needs to turn the other way around. That works. That works. Ah, now you can see that this one is definitely rotating the wrong way around. That's the problem that I was expecting to happen. But seeing that the other two axes are actually pretty usable, that is really working very nice. And it feels about the same as I'm actually moving my joystick. Don't look outside the ship because else we get very dizzy. So we just need to do the Z-axis slightly different. And the way we do that is we actually want to rotate that around the current local Y-axis of our flight stick. And the way we do that is by changing our basis directly. So in this case, we're just going to go to transform basis. And we're going to start with the basis that we have right now. Actually, let's copy that into a variable right now. Call it B. I don't want to call it basis because it might clash with something of our main thing. So let's put a remark here why we're doing this. Z is rotated. All right, so B is already defined in the scope, is it? Have we already used B here somewhere? Because we got our global trans. Okay, so we do need to do that. Okay, so we're going to call it flight stick. Oh, FL for flight basis. Okay. Thingy needs to have a name. Normally I like writing out my names like we have these things, pitch vector, roll vector. But when it becomes to these sort of things, I like to use shorthand because all the code, depending on that, is very close to each other. Although that said, no, we are using those there as well, so that's pretty good. Alrighty. So what we're going to do here is flb.rotated, and that then needs to rotate around a vector, and the vector that we want to rotate around is our y vector of our basis. That's currently our local y vector. And now we're going to go and rotate that by yaw, and I'm going to go on a limb here and make that negative because it was rotating the other way around. So I think that is something that I need to do here as well. All right, let's see if we got that right. All right. Okay. That was not what we had in mind. Now it just rotates all the time. How are we going to fix that one? I'm wondering if we should just move it up. Well, it might actually do that. Let's actually try that, because in this case, I would have to get the rotation back. Do we have that in our bases? Maybe we do. Maybe we can do this simpler. Maybe you can do this simpler. Can we? No, I don't think we can. Okay. That's a good one. Actually, no, we are going to make our life easier. We are going to do this differently. That would have worked if we actually wanted to keep rotating. As you can see, it was spinning like crazy. Yeah, you can post it in chat here, or just email me on mux213@gmail.com. That is fine as well. Okay, let's go back to the 3D side of this. And all we're going to do here is we're going to just add in an extra spatial. And then we're going to add that in here. So because I added that spatial directly on there, it is actually on our thing. So this is going to be our Z gimbal. There we go. So now we're going to make our forward, backwards, left, right movement work on our flight stick. But we're going to do our turn of our flight stick on our gimbal here, which means that it's applied before the other rotations. So let's see if that works. C gimbal rotation. Oh, I need to call that Y gimbal. I always mix those up. So let's rename that one to Y gimbal. There we go. Minus yaw times 0.5. So that's a way to layer these rotations so that actually gets applied in local space of the flight stick, and after that Z rotation, or that Y rotation, does help if I actually change that to Y. Thank you very much. Then the other rotations are applied. So let's go and have a look whether that is now the result that we're after. Come on, open VR, find my tracking. There we go. So now that is nicely turning exactly the way that I want. And you can see that it's now turning around itself, even when I move my joystick. It is turning the way that we want it to. So we're turning left, we're turning right. And if we look outside of our ship, we're getting very, very dizzy. So we should have all our flight controls working. There we go. Here we are. Alrighty. Now, one other thing that we really should be doing, but I need to prepare some more graphics for that before we're ready to do that, is when you look at the left side of our controls, we have that speed slider with the 1, 2, 3, 4, 5, 6, 7, 8, 9 there. And unfortunately, number 4 is already highlighted, which is the thing that I need to fix up in those graphics. But obviously, our speed control should be displayed in that as well, so that we don't have to look down at our throttle to see at what speed we are at. We actually have it in our field of view when we are looking out of our fighter. I'm not quite sure what the P is for. Whether that's, I guess that's a power level for, you know, because that's something that you see in many games like Wing Commander and Star Lancer, where or even I think even the X-Wing fighter game did it, where you can decide whether you want to have the power go to your guns and therefore you sacrifice some speed, or whether you want the power to go to your shields, or whether you want the power to go to your engines. We'll have to have a look if we want to implement those things. Now, obviously, we have no reason to stick to the graphics that came with the cockpit here. They are part of the game that this cockpit came from. But yeah, we'll have some fun with that in another episode where we actually start looking at all the displays. Yeah, Dropbox works fine. I use Dropbox all the time. Shouldn't be too hard. Okie dokie. So that is it as far as updating our controls is concerned. They are now all working. Here we can see the old background that we were using before. I'm gonna leave our ship alone for a little bit. We should make our environment a little bit more interesting. Now Union Bytes has been kind enough to offer some of his asteroids. So we'll probably be replacing the asteroid that I'm using right now with the one that he'll come up with. We've already got a planet in the background, so let's get some asteroids in our field here. And here we're going to do two things. One is we're going to use a multi-mesh in order to render a whole lot of asteroids. And I'm going to use one for now, even though when we look at creating a larger number of asteroids, or creating, you know, like a total asteroid belt to fly through, we will have multiple, because we can then work with, you know, adding some level of detail in there, that the mesh, the multi-meshes that are further away, they get, you know, maybe just a billboard asteroid or something like that, and the ones that are closer get the more details asteroids. But for now, for step one today, we're just going to add a whole bunch of asteroids in with a multi-mesh, a single one. But the other thing that we're going to do here is we are going to add a tool script to that that allows us to tell Godot where, to basically randomly place the asteroids and how many it needs to place, because obviously placing hundreds of asteroids manually, that's not really, you know, a very good idea. We also need to start looking at how we are going to handle collisions with our asteroids. That's also going to be interesting. Okie dokie. And yes, Union Bytes, having roughness, ambient, occlusion, and metallic maps would really help make our asteroids pop, because the one that I'm using right now just has a color texture and it's going to be ugly, but it's a start. I didn't want to use the one that I used in my tutorial for rendering lots and lots of asteroids, because that one that was actually a incredibly high poly asteroid that I had decimated in Blender, but it had a lot of problems in normals not matching up and stuff like that. So actually, if you look at it from certain angles, it doesn't look very well. And because now we're able to fly around, that really is going to start standing out. So let's add in a multi-mesh. And we're going to call it Asteroids. There we go. And I'm not going to save that to disk just yet. I do want to save this as a subscene so that we can reuse it and instantiate it multiple times. But we're going to start with just having the one over here, which means that we're going to go and add a new multi-mesh in there. There we go. That needs to become a local to scene resource. We are not going to be using the color format at this point in time. We may do something with that later on. We may start looking into using some shaders to animate our asteroids. Our transform format needs to be 3D. Custom data format is none. Instance count is 0. I'm wondering if I should. Nah, that's all right. Let's go and load in a mesh. And I've got that over here. That was one that I downloaded from 3 as the. Now I haven't actually opened this one in Godot yet, so I've got no idea how well that looks. Ooh, it's way too big, that's for sure. There we go. We got an asteroid. Yeah. I can live with the size for now, to be honest. It is interestingly centered really weird. So let's see if we can fix that up. So assets, free 3D, asteroid, that guy. Nice mesh. So we really need to center this one. I think it's too far away that way. So how big would that be? -100? I don't know. Definitely a lot more than -100. There we go. That looks pretty centered to me. Yeah, I'm happy about that. Now, the reason I'm not worried about the scale is we're actually going to scale the asteroid in script. Yeah, no, particles are also a possibility here. The reason why I'm using multi-mesh is because I want to have control over the positioning of the asteroids. Because eventually, we don't want to fly through these asteroids. We actually want to collide with the asteroids. Now, the problem that we have is if we have a very large asteroid field, having every asteroid as a collision shape would probably... Well, I don't know how well Bullet will handle it. It could possibly handle it pretty well. I'm not quite sure. But I'm not really going to try. So the idea that I have is generally whatever is important is the area that you're actually in. So when we have a large asteroid field, we're going to have clusters of multi-meshes, each responsible for a small section of space. And when you're close to that section of space, we are going to add the collision shapes for those asteroids in our we're going to add them to our physics engine. And when you leave that space, when you're far enough away from that you can't actually hit those things, we're going to remove them. Now, obviously, that means that we have to be careful once we start adding enemy fighters in there and targets to shoot, that if we're too far away from the asteroids that our enemies are at, that our enemies no longer collide with our asteroids. That's something that we need to look at. But I think for the type of game that we're making here, the number of enemies that we are going to be controlling, either we're going to make sure that we check both the distance of the player and the distance of the enemies to decide whether we're going to add the collision shapes to our physics engine or not. And we're going to be doing that with areas. Or we're just going to accept that that's going to be happening. When our enemies are far enough away from our player and they happen to clip through an asteroid, you probably wouldn't even notice because they're too far away. So that is a bit too much forward thinking. yeah, so we're going to purely use the collision shapes for the closest asteroids. But again, you know, with... Sorry, I'm running over my cable here. Excuse me. But the thing is, when we're using multi-meshes, we have access to the information that we need. And when we are running particles, we don't have access to the information that we need. So that's basically why I think that right now that multi-meshes are the way to go. Render-wise, it doesn't make a difference. The only problem with the multi-mesh is that it takes time to update the buffers. But seeing we're going to generate those in script and they are going to be stored alongside with our scene, I'm not too worried about it. Might make our scenes very big. As far as I'm aware, when you actually export your game, most of that is converted to a binary format anyway. So that should be relatively safe to do, unless we're going to have millions of asteroids and we're going to end up with millions of yeah, a couple of megabytes of asteroid data. That might become a problem. But I don't want to think that far ahead yet. Let's get this bit to work first. So yeah, so I've centered my asteroid. I'm not going to scale my asteroid because we're going to change the sizes of the asteroid anyway. But it's important that it's centered because eventually we're going to be using a sphere as a collision shape, because there really isn't any point to have an accurate collision shape for these things. And when you're getting close enough to the asteroid, you want to bump into it. Maybe at some point we want something that's more fitting. If you really want to skim over the surface of an asteroid, I think if we want to have a few asteroids that are large enough for that, because obviously, you know, I don't actually want them this large. If we have one or two, then those are just going to be normal meshes with proper collision shapes. If there is a need for gameplay there, you know, X-Wing, I think had, you know, where you could actually fly in between some of the asteroids. So then we need some more accurate collision shapes. But then we also need to make sure that all our meshes are the same size. So I think in that case we would be placing a couple of normal meshes very strategically. Okie doke. I actually want to get our center changed here. I don't want that right on our ship. I want our asteroid field to be somewhat outside here. There we go. And let's add a script to that. Actually, let's actually save this first as a branch, because I think that is nicer. Let's create a MISC folder in here because we'll be reusing this plenty of times. So there we go. There's our asteroids. So we're gonna multi-mesh in there. We're gonna get our script variables in there. That's fine. Let's go and save this before we forget. Now let's create a script on this. Great. And that is going to become a tool script. Now, unfortunately, because of what we're doing, we're going to have to reload this one a few times, or else things are going to get a bit crazy. All right. Let me drink some water. All right. The first thing that I want to do is I want to include an isReady for and an onRFunc isReady. Oh, ready. I'm going to set isReady as true. There we go. And the reason I want to do that is because we're going to add in a number of export variables, which will allow us to control our tool logic. And I don't want to run that the first time. And the nice thing about Godot is it will the first time it sets our current values, it will call those before ready is called. The reason why is because once we generate our asteroid field, that is all saved as part of our multi-mesh instance. That information we are going to save in our scene, and we're going to just load that next time around. We don't want, when our scene loads, we don't want to generate them right then. We only want to generate them when we change one of the variables. We want to remember the generated data. So that is why I've got this in there. The downside of this is that with tool scripts, because the tool script right now is already loaded, it tends to, whenever you make changes, it tends to forget what this is and change our ready variable back to false. And it won't call ready again because it's already loaded. It's a bit weird. But we'll work around it. It just means that when we make certain changes, we have to just reload our scene once in a while. Okie dokie. So the first export variable that we're going to make is number of asteroids. How many asteroids do we want to have in this particular scene? I'm going to set that to 0 right now. That's our default value. And then I need to get a setGet to allow us to create a setter function. These are becoming quite long names, so that we can now go and define our setter function here. And the first thing we obviously are going to do is set our number of asteroids value here. But now we do the rest only if isReady is set. So let's go and have a look at our asteroids, at our multi-mesh. The first thing that we need to do is we need to change our instance count to whatever number of asteroids that we are setting. And that gives us our initial array of asteroids. So multi-mesh dot instance count is number of asteroids. So that resizes the buffer that we have. And now we want to generate the asteroids. Now for that, I do want a new function. Because we're going to be calling that from different places. But we're just going to start with this. Okay. And what we're simply going to do here is in, I think that is called range 0 number of asteroids. There we go. So we're going to loop through the number of asteroids because we're going to place each and every one of them. Let me go and find our multi-mesh help because I always forget what they're called. So we have these functions called set instance transform that will allow us to update the transform for a particular asteroid. Okie doke. Now I always forget whether the first instance is 0 or the first instance is 1. We will see. But we're going to start with generating a new transform. And then at the end, we're going to say set instance transform index t. And the first thing that we're going to do is we're going to change the origin point of this to a new vector 3. And we're going to use rand range to get a value, a random value between two options. And I'm going to make it very small right now because I just want to demonstrate this. We're going to add settings for this in a minute because we want to be able to set how big our asteroid field is. All right. I'm just going to close our scenes again just to make sure that it reloads. Come on. Takes a while to load. There we go. All right. So there is our asteroid. We might have moved that away a little further than I would have liked. Let's actually go and just position it like this. That's the downside of having such a big asteroid. And then with a size 10, that's not going to work, is it? You know what? Maybe we should make our default size of our asteroid much smaller. So Let's go and do 0.01, 0.01, 0.01, and that means that this needs to become -5. There we go. Now we have a small asteroid, which is not as well centered as I had hoped. And that's the wrong way. That looks about right. All right. So let's create 10 of these guys. There we go. We've got 10 asteroids all clustered together. And that is because our maximum sizes are a little bit small. So let's go back to our scripts. Let's go back to our asteroid script. And let's put a variable for that in here. So we're going to say export variable distance. Actually, let's call it extends. And I'm actually going to make it a vector 3 so that we can. It's a reserved word, isn't it? Let's see. Does it not like the variable name? It does not like the variable. Can I just call it extend? I can call it extend. I guess extends is a reserved word. That's interesting. Let's just say 100, 100, 100. And then here we're going to say minus extend x to extend, extend x. Here minus extends x, y. So while we're going to place them all within a box, we could size each axis individually. There we go. Okay, and then we're just going to do a set get, set extend. So I want to do the same thing here. Create a function, new value, extend is new value. Let's actually give this a type. Let's do that here as well. Is it int? Yes, it is. And here we can just call our generate asteroids if we are ready. Okie dokie. Let's see if that works right away. Like I said, it might require us to reload again. So let's make that 15. I was afraid of that. So we just save it and we reopen this. So like I said, whenever we change our script, it reinitializes our variables. So all of a sudden our is ready became false, but it's not actually calling ready because the scene is already loaded. And therefore our script stops working. But now, every time we change this, we get a whole bunch more asteroids. We could go pretty crazy with that. As you can see, it doesn't take long to get a whole bunch of these. And it's still pretty fast in rendering these because they're very low poly. I wouldn't want to create 10,000 collision shapes, so I'm not quite sure how well that would go. So that is why I would like to have a single one of these, just have, you know, maybe about 100, and then we could create another one of these and just place it behind it, create another 100 asteroids, but have them recreate our random positions so that they all look a bit different. Okie-do. And that is also seeing that we've created our mesh instance or a multi-mesh as a local to scene instance. That should all work. Now, one thing that I'm very interested in is I'm going to go in here for a sec, and we're going to go in here, and we're going to go in scene, and we're going to go to a start scene. We're going to open it up. I just want to have a look at what it actually puts in here. So one of the things that I noticed right away is that our multi-mesh resource is completely in here. Now I'm not sure if that is because the moment that we generate our array, so here we can see all our random data that we just created. Could be that the moment that we create that, it decides to create the whole thing, but it could also be because we just created our multi-mesh in our main scene first and then saved as branch, that it may have kept that in there. So the way to make sure that that goes okay is to do that. So now we're taking the multi-mesh from our main scene, and unfortunately that doesn't decide to reload it. So we should no longer have our multi-mesh in here. But now I'm really interested to see what happens when we generate our things. So let's actually do that like this. Let's see, where are we? Okay, that's interesting. So we got our number of asteroids set over there, but that's for our asteroids. I'm really wondering about that. Has that now? We don't have any. Yeah, it's applied on this, even though that is local to scene. That's interesting. That is interesting. Because that would mean that if we have multiple of these, it would not be updating our local multi-mesh. Does that mean that we always need to create our multi-mesh in scripts? Probably. Oh, let's do that. So let's clear that one. So now we no longer have a multi-mesh. We have it empty there. But what we're going to be doing here is in our isReady. So this is the very first time that we add our asteroids here. We are going to add a multi-mesh, and we're going to see if it does that in the start scene or if it does that in this one. And I think we're only going to do that if that does not equal 0, so that we never add it into our base script, and multi-mesh is null. So if we don't have a multi-mesh yet, we're going to create. Is that a? I think it's that. All right. Double equals. I always make that mistake. Why don't I wrap text on the next line? Yeah, I guess I could do that. I kind of like having things on one line. I don't know. It might make it look nicer. So you mean like this? Boom. See how well that works. I guess that looks nicer. Makes it a bit more readable. That's not a bad idea. Okay, multi-mesh dots. What do we all need to say? We need to set our transform formats. Is okay. Does that need to be multi-mesh dot trans? Here we go. So we need to set that one. Do we need to set anything else? I think all the other things were fine by default. Okay. Let's actually put that in a function. here. Because, oops. You can actually move that here as well. Actually, that needs to be just always here, I think. You know what? I think so. Let's just move this whole thing in there. That's probably a better idea. So the very first time we set the number of multi-meshes, and we don't have anything yet, we create it. That's actually nicer, I think. Create a multi-mesh, set our transfer format, set our count over here, generate our asteroids. That should all be fine. That should be fine. Let's see if this works. This is quite a bit of experimentation. So when we go back in here, yep, boom, boom. Let's open it back up. So obviously it won't do it right now because we are assuming that we just added it in and we needed it to start it. But the moment that we set that to 100, I was expecting it to create a multi-mesh. So is that now just because? Yeah, it has. That was just a redraw problem. Oh, but we of course need to assign our mesh. We forgot to assign our mesh. So we're going to go and clear that again. Clear. Think. Let's go and close that already so that we know that we can reopen it in a minute. Go back to our asteroids. So the very first time that we create this guy, mesh is preload. We're just going to drag that in from here. Our objects. There we go. Actually, no. Oops. Support var mesh. That is going to be. It's not a vaccine. What does that load? Mesh. There. And the reason I'm doing this is because we can now use different meshes for our asteroids. So we're not always using the same mesh for every asteroid field. Set mesh. So obviously we want a function here as well. In this case, we are not going to regenerate our asteroids. We're just going to set it. So mesh is new value, and then in this case we're just going to check if our multi-mesh exists, and if so, we will assign it, which is multi-mesh.mesh is mesh. There we go. And we already have that here. So if it's still null, it won't be set. If it is set, or if it is there, it will be set. So that should be good. All right. Let us see if that works. Come on, load it up. There we go. So when we go back to our asteroids, we see that our mesh here is empty. Our multi-mesh is still empty. Let's change that back to 50. Now we know that we need to go and reselect that to see that it's now loaded in. We've got our 50 things, but we don't have a mesh yet. But we can just show and set it up here. I wish we could actually hide those. So I'm wondering if we should move that into a subnode just to not have that in there. Let's go back to our asteroid, put our asteroid in there, and there are all our asteroids. All right, we're getting somewhere. So now we do end up, and that is again, I do like Sublime better. I need to go back to Sublime. So that does mean that our whole multi-mesh ends up in here. That's fine, but we want to have a unique multi-mesh for each of these scenes. So that is kind of important to have. But it should mean that right now, if we add another asteroids field in there, and I didn't want that there, I just wanted to have that here. So that's interesting. Why did I move it all the way? Oh, that's because our, okay, let's fix that up, because that's gonna trip me up on other days too. There we go. I'm actually gonna go and delete this link and just re-add it in. Nope, that one. There we go. Let's go and move that somewhere over here. There we go. And let's give this one. So let's try see if it works if we do it the other way around. There you go. There's our asteroid. And let's make this 60. Boom. So now we have 60 asteroids in this little cluster. And we got 50 asteroids in that little cluster. And that means that if we look in here, which of course, again, I need to reopen. There we go. We now see two sets of data in here. All right. Now we want to make sure that our asteroids are not uniform. Because when we look at our asteroids here, they're all the same. They are the same size. They're oriented the same way. That's really boring. So when we go to our scripts and we go to our generate asteroids, as far as our rotation is concerned, I don't really care about the range. Oops. So we're going to change this to origin. Actually, do we have it rotated? That's a function? No. Basis dot. I thought there were access methods for those. Let's have a quick squeeze to that. Now we just have a function that will rotate this. Let's go and have a look at our bases then. All right, so let's randomly rotate it around the random axes. That'll work. That'll do it. Just on this one. Now we do want to do that on our basis, else we're going to get into trouble with that. So we're just going to say new bases, rotated. Now let's do the same thing that we did before with just our nice little slashes. We need to generate a vector 3 here. And we're going to say rand range 0 to 2 times pi. Let's see. You're going to go over there. There we go. Go over there, and I just don't want to do this. 2, 3. So, no, this wouldn't be pi. This can just be. This is a random axis, so that's going to be -1 to 1. And then our rotation needs to be a random to pi. Actually, let's go and copy this before I do some more of that. Now, I think I could be wrong. We'll find that out soon enough. Actually, let's be consistent there. Let's always move our commas at the end. Picking. There we go. What am I wondering about? Do I need to normalize my vector? I don't think so. We will see. Now again, we probably have to reopen our scene. It's kind of annoying. indeed, I need to reopen my scene. Okay. Save and close. Now, obviously, once we've got our script intact, that's no longer a problem. We can just create our asteroid fields as we want them, and we don't have to worry about having to reload things because our script will be correctly there. Okay, axis vector 3 must be normalized. I said it. I called it. I thought that was going to be our problem. Come on, close it. Save and close. Let's get back to our script. Our asteroid script. A little silly, actually, that it doesn't just do that. But I don't know. Because, you know, for it to figure out that it isn't normalized, it has to already calculate the length. It might as well do the normalization at that point in time. But oh, who am I to complain about that? So okay, so all our asteroids disappeared because of that problem. So there we go. And now we can already see that each asteroid is now rotated randomly around a random axis, a random number of degrees, and they're all different. All right. Now, one thing that I haven't done, by the way, which maybe we should do, but I think it's a little bit overkill at the moment, is to see whether there's any asteroid that overlaps with another asteroid. Maybe that's something that we really should be testing at some point, but not too worried about that right now. So the last thing we're going to do is we're going to add actually a min scale. Oops. And we're going to add a max scale. Oops. And then obviously we want some functions for that. Oops. Set min scale new value vector 3. Min scale this new value, and regenerate our asteroids, and we do the same for our max scale. There we go, which now means that we're going to go and apply our scale here, and we're going to do that one on our bases as well. But in this case, we're going to do that directly on the bases that we have, but we want to have a scaled version of our bases. So again, let's do that. Vector 3. Oops. All right. And in this case, we want to have a rand range, min scale, max scale. There we go. I need 3 of those. That's going to be Z. That's going to be Y. We don't need that comma. Y, Z. And there we go. Let's see if it clears the error, or do I have... didn't like the space there, I think. There we go. Perfect. So that gives us a randomized scale on all 3 axes. Now, I'm allowing us to set these different per axes, which means that we can flatten our asteroids or things like that. That does make it harder to use a sphere as a collision shape, because obviously if we end up with a flat asteroid but we have a complete circular collision shape, that might become unrealistic. Then again, it is going to, we're going to make it spin at some point. that mean at the end we are writing code on the next line? Yeah, so the slash indeed, that allows us to break up a single line of code so it becomes more readable. Because if you look at a language like C or things like that, your brackets already denote that. So those languages don't care if you put things on new lines. But because we're using a Python-based language and indentation is very important in Python-based languages, doing something like this would break the rules of Python. And the slash simply means, you know, the next line still belongs to that line here. So it basically will remove all of this before it evaluates the line of code. That's all that slash means. But for us, having this broken up into multiple lines, it just makes it easier to read the code instead of having a really long line of code because of the number of parameters that we do and the fact that every value we're using a rand range, which is a pretty long instruction. It becomes more readable if you distribute it over multiple lines. So I really should be doing that more often, I guess. Old habits die hard, I guess. Not used to doing it, but it is a really good idea. So I can't remember who made that. Union Byte, was it you? No, I can't pronounce your handle. Detmozai came up with that suggestion. So thank you very much for that. That was a really good suggestion. Alrighty, so let's try that again over here. Let's change it to 60. And now we can see that we have some bigger ones, some flat ones. We have some small ones. So yeah, now I actually want this to be over a bigger area. So I'm gonna make that 300, 300, 300, because I want to be able to fly through these guys. So there we go. We've got some more of these. And let's do the same thing. Actually, rename it to 01, 02. There we go. Okay, so I want to move that out of the way a bit as well. And we're just going to make that bigger and bigger. Now we could lay this out on a nicer grid. But for now, we're just going to... was that 300? Yeah, it was. Okay, let's make that the same size. So that looks like it's part of the same asteroid field. And obviously we could create a couple more like this, but I just want to have these two first. Actually, no, let's create some more. So we just duplicate that. And when we duplicate it, we just change the number of asteroids in here, and that should generate it. So let's actually, I wonder about that. Okay, so that's something we shouldn't have done. So let's go and clear this. And now I'm going to change this. And now we create a new multi-mesh. So because I duplicated that asteroids field, I also duplicated the reference to our multi-mesh object. And that meant that both of these were using the same multi-mesh object to position all the asteroids. So yeah. Well, yeah, with the 3 different asteroids, you know, obviously we can have 3 multi-meshes share the same space, each with a different asteroid, you know. So we could have this one overlap the other one, and then have this one use different asteroids. And that way you get a mix of different asteroids in the same field. And we're really getting to a point here where it doesn't matter if we get quite a lot of these. So obviously we'll create another one, and this time we are going to clear that right away. There we go. And let's move that back to 60. And here we are slowly increasing the number of asteroids that we have. Now we could create a whole lot more, and we might create a whole lot more. We might also make them somewhat bigger. Let's actually go to this one and actually say that we don't mind this to be quite a bit bigger. There we go. Maybe we should do that for all of them. Oops. Let's make them 4 as a maximum size. So we have some substantial sized asteroids in here. There we go. I might actually move that out a little bit because they're overlapping a little bit now. Maybe move that a bit more like this. There we go. Maybe this one a little bit more. And again, eventually we can build quite a lot of these. Alrighty. Okay. Okay, let's go and have a look what that looks like when we actually fly around there. Alrighty. Alright, just gonna find my headset in a minute again because I need to wake up. Come on, there we go. Alrighty. Oh, we can already see our asteroids outside. Look at that. Alright, that looks pretty cool actually. They're better sized than I thought. Now obviously we can fly through them because they don't have any collision shapes yet. But yeah, they're not too big, they're not too small. We can actually fly through our asteroid field here. Now I could, just for fun, just go through one. Oh, I'm actually going right around it. Yeah! So yeah, we don't get any collisions with these guys. Now, one thing that is going to be important is we're going to be using static bodies for the collisions with these things because yeah, that's pretty cool. Because if we would knock them out of their orbit and push them away, then you suddenly get the problem that you have to update the positions on the multi-meshes. Although again, you know, one of the possibilities that we do have that we could look into, and I don't want to do that tonight because it's going to get way too late for that, is we could add a level of detail mechanism here. So when the when one of these things is far away, we use billboards. Then when they're slightly closer, we use the multi-mesh. And then the one that's closest to the player, we disable the multi-mesh and actually turn it into having a whole bunch of individual meshes. And then we could probably animate those. But not quite sure if I want to go down that path. What time is it by now? Okay, we've got about half an hour left. So the only thing that I want to do now, if we can, it's a good one actually. Let's have a look. How would that work? I want to make them rotate. Now, the problem that we have with that is that we don't have a way to overwrite our material just yet. So we might need to do that one in code. That's a good one. That's a good one. Because we don't have an overwrite material on our multi-mesh, do we? Oh, that's because that's double there. Okay. That's just our resource. It's fine. We do have a material override. Perfect. I was wondering about that. So if we create a shader material here, we're actually not going to create that here. Wait. Clear. No, actually, let's prepare that here. We're going to save that one, and then we're going to load it into our base, because else we can't see what it's doing. So, okay. So let's go in here. Let's create a new shader here. Let's actually save this first. Save as. Actually, no, just save. Boom. Scenes. Misc. Yeah, we'll put it in here because that's where we got our asteroid script as well. So that's going to be asteroid material. There we go. And now our shader. So I want to go in there and I'm going to save. Actually, let's give that some text first because also it's going to be saving an empty file. I'm not sure if it's going to be happy about that. There we go. And we're going to go save that one. Why is that? That's weird. Okay. Hang on for a second. Okay. Let's restart that. Okie dokie. So let's see, did that not? Yeah, there's our material. There's a shader. Okay, so was that just because of the order in which I did that? This feature cannot be saved because it doesn't belong to the edited scene. Okay, so does that just mean that I need to open that in a different order? That's possible. Okay. Misc. What if I open it from here? Can I save it now? Okay, you know what? I'm gonna do a save as. Oh, that doesn't even like it. That's interesting. Okay, that's a mental note for the future. Save them in the other order. I am very surprised that it doesn't like us doing that. So, make unique. There we go. Save. Now we can do it. So that's going to be called Asteroid Shader. Kiddo. Asteroid shader. Maybe it would have been enough to just call it asteroid.shader. Well, that's fine. That doesn't really matter. Okie dokie. Now, the reason I am splitting these two is, again, looking at the future where we might use different types of asteroids, like when I download Union Bytes asteroids. Each asteroid might have a different set of textures, but we want to reuse the same shader. So we would end up with multiple asteroid texture materials, and yeah, we'll see. For now, let's just go and set this up. Now we only have an albedo texture at this point in time. We don't have multiple textures, so we are just doing that one. But later on, it will be very easy to enhance the script to allow for the other textures as well. What? Aren't you going to? Is that's a capital D? Okay, it is case sensitive. That's always the downside of shaders. I'm wondering actually, should I make this a visual shader? No, we're gonna leave this as a normal shader. It's fine. So our first one to get our fragment shader up. Now the thing that I really like about shaders in Godot is you're not writing the whole thing. Almost all the logic around shaders is still in there. We still have it. We're just making the changes that we need to do. So in this case, we just need to set our albedo color to our texture. And we just use our UV. And we just get our RGB value. Now we don't have a texture yet, so this is not going to do anything. So we'll save that, and now we're going to go over here where we have our material. And oh, that should still be our asteroid material, so that's fine. So here we go to our assets and our free. There we go, and we're going to go and put our diffuse in there. So now we should see that all our asteroids that were previously white are now nicely colored. And it should be exactly the same as these. They're not, and the reason why they're not is because our original material, which we can see if we go to our original asteroid, and we go to the original material on the asteroid, we will see that we actually don't have a fully white color. So that color gets multiplied with our asteroid color. That's really interesting. Now, I don't know if that is on purpose or if that is because when this was modeled, they use that color. And usually in like an application like Blender, when you set a texture, it will override the color of the object. It won't mix it, but Godot mixes it. Godot takes the albedo color and multiplies that with the texture color, and that is the final color that we're using, which I think I'm not going to do for our asteroids. For our asteroids, we're going to use the color as is. Although we could change all our, we could put a random color in if we really wanted to. I think that's overkill. Alrighty, let's get back to our shader, because the thing that we really wanted to do is we want to start rotating our asteroids. Yeah, so when we look at the multi-mesh, note that if I move the multi-mesh, I move the whole set of asteroids in this multi-mesh. So if I would create, around this planet, now this planet, like I said, it is locked in with the player's position. So this moon moves with us instead of it staying in a single position. But let's say that we actually have that normal and we could fly around this planet. If you put a whole set of multi-meshes around the planet and we child them to the planet, we could rotate it to the planet and rotate the all the meshes around, which really is actually kind of cool. If you don't want to rotate a planet, you just want to rotate the asteroid belt around the planet, you just add another spatial and make the multi-meshes. So actually we can show that real quick just as an example. So if I create a spatial, and I don't want that there, I want that separate, and I move that out of the way a little bit and say that that is my planet. There we go. And then I have my asteroids as children of my spatial here. Then if I rotate my spatial, see how all the asteroids move with it? So if my planet is rotating, my my multi-meshes rotate with it. Let's delete that again. There we go. So yeah, that's how easy you can make that work. And again, if you break that up, let's say that around your planet you let's say that you put every 10 degrees, so you have 36 multi-meshes around the planet, each having a small cluster of asteroids. That means that the ones that are behind the planet could be rendered at a lower level of detail, while the ones closer to you are rendered in full detail, just by changing the mesh that is being displayed. But the other thing is that if you are in a place where some of the multi-meshes are behind the camera, Godot is actually smart enough to not render them at all. While if you would have all the meshes, all the multi-meshes, all the meshes, all the asteroids in a single multi-mesh, so I would create a single multi-mesh and then place all the asteroids around the planet, and let's say that those end up being 10,000 asteroids, Godot will render them all every frame, whether they're outside of your camera view or whether they're inside of the camera, whether they're behind you, whether they're to the side of you, it will render each one. So breaking them up into smaller chunks, you still have the benefit of batch drawing, the fact that we are drawing, in our case, about 60 or 70 asteroids in one go. And we could probably make these bigger. If we really want a big asteroid field, we probably can put, let's say, 1,000 asteroids in a single multi-mesh and make the area that multi-mesh governs much larger. But by still breaking it up into multiple multi-meshes, you have the advantage of that things that are outside of the view frustum, they don't get they get called out, they don't get rendered, and you just suddenly have blocks of asteroids either being rendered or not rendered, or if you do an LOD thing and the further away, let's say that this one will be further away. All you need to do is change the mesh, and it's suddenly, and if those meshes are already loaded, it's just a pointer that changes. And just in that draw call, it says, draw this mesh 1,000 times. The GPU doesn't care which mesh is being rendered. It just cares that it's rendering one mesh 1,000 times. So that's a really easy way to do LOD, is just calculate the distance of this multi-mesh to your player. If it's beyond a certain distance, you switch to a lower level detail mesh, which I do plan to do here, just not tonight because we've got about 20 minutes left. I just want to get the rotating to work. It's not occlusion culling, it's another form of culling. So Godot has got Frustum Culling, so any object whose bounding box falls outside of your view frustum gets culled out. So if I'm over here and I'm looking forward, then this asteroid multi-mesh, this guy is in view of myself, those get rendered. The other ones are outside of the view, they don't get rendered. If these were individual individual mesh instances, so let's say that instead of having 4 multi-meshes, I would have, got about 400 asteroids, 300 asteroids right now. I would have 300 mesh instances. Then each one of those individually would be culled against our view frustum, which means that we are rendering less than we are rendering right now, because if my camera is inside of here, so if I'm inside of here, I'm only rendering this multi-mesh, but I am still rendering all the asteroids that are behind me within this one multi-mesh. But if these were individual mesh instances, only the ones that you're currently seeing will be rendered, the other ones will be culled out. And this is a balancing act. So when we're looking at 300, 400 objects, it's probably faster to have them as normal mesh instances. But we're just testing, that's why we only have 300 asteroids. When we are going to 10,000, 30,000, 100,000 asteroids, you want to divide them into multi-meshes because you want to batch draw them. And then you don't care that if you draw them 1,000 at a time, that a couple of those are drawn for nothing, because you are ruling out so much of the other multi-meshes because they're further away, or they're behind your camera, or they're outside of view. Those don't get rendered. Occlusion culling is a very different thing. And I can demonstrate that very easily. So when I look at this right now, I see all my asteroids, and I need to render all my asteroids. When I do this, my carrier is now blocking all these asteroids. Godot still renders those asteroids. Now, depending on the order in which we draw things, if we draw the carrier first, then the Z buffer filtering, the depth buffer, will make sure that as we're rendering all our asteroids, not much happens. They get discarded very quickly. So all the code that's actually in the shader is being ignored, which does improve speed. However, we're still rendering all 300 asteroids because they're still actually in our view frustum. It's just that our carrier blocks it. Now, occlusion culling is a technique where we first check whether our objects are being obscured by another object. So in this case, whether our carrier is obscuring our asteroids and not drawing the asteroids at all, if that's the case. And again, it's a balancing act. It's what a lot of people don't understand. They say, Godot doesn't have occlusion culling. Oh my God, it's going to be slow. Well, first of all, the overhead of drawing these asteroids, even though the spaceship is in front of it, 9 out of 10 times they're in view. So 9 out of 10 frames, we are going to be showing all the asteroids. It's only when we pass behind the ship that we might have a little bit of gain in not rendering them. So in our game here, occlusion culling won't do much. But it costs performance to do occlusion culling. That's just what people forget is, yeah, you save rendering time, but you introduce a new layer of execution, which is why when you look at Unity or when you look at Unreal, which do occlusion culling, they're not culling on the full meshes. You are selecting which objects are what they call occluders. So you would say my carrier is an occluder. It can occlude asteroids. And I am marking my asteroids as the things that I want to be occluded. And I would basically do a simplified render pass on simplified versions of those objects to detect whether one thing is occluding something else, and it would, skip them at that point or remove them from the render queue. It's actually a very costly thing if done inappropriately. When you look at an indoor scene, you build a game, an FPS game where you're running inside of a building. Occlusion culling can make a large difference because all of a sudden you can call out what is in a separate room, even though it's in front of you. There's a wall that is blocking your view. You don't want to render all those things that are in the next room because there's going to be a wall drawn over it. So that is where occlusion culling can be very efficient. But again, as I proved in my other tutorial, there are other ways of dealing with that as well if you don't have that technique. So little lesson in what are the different forms of culling. There are quite a few. But in our space game, occlusion culling won't do much. That's one thing that I can promise you, because of the way that things work. The chances of one object occluding another object, it only happens in some frames, and it's not worth the extra CPU to do that sort of culling. There are better ways to optimize the game engine. Anyway, let's get back on track and implement our Vertex shader. All right. Now let's see if we actually have a function for this. No, that's not it. Here's my thing. Okay. Do we have a list of built-in functions here? That's a good question. Because what I need to know is if we have a function that allows us to rotate stuff. Else we have to just write one ourselves for a second. We might have to write that ourselves. All right, so I might be taking the long way road around, because I am pretty sure that there has to be a rotate function in. Let's see if there's a glass OpenGL GLSL rotate. That is in. I want to know it in code. Okay. Well, that's building a whole matrix. No, let's okay. I'm just to save time because we are running out of time tonight. We're going to be doing this the old-fashioned way and just hand writing our rotation code. But this can be improved a lot. This is taking the long way around. So I'm going to go and copy our vertex. So vertex is a special type of variable in our shader. So when we look at, I'm actually going to go and make this a bit bigger so we can see what we're doing. So in our fragment, we used a variable called albedo, which is an output variable. So whatever color we assign to the albedo variable, there's a whole bunch of them, that goes into Godot's lighting stage. So we are actually not doing anything on the lighting stage here. For anybody who's written GLSL shaders before, they would recognize that normally you only have a vertex function where you do your modifications on a single vertex of your object. And then you have a fragment function where for each pixel basically that you're rendering, you are deciding the color. That's where GLSL ends. Godot has split that fragment shader into two shaders. So the fragment shader itself, which is only in which you only calculate your base color information, so your base PBR input, so your albedo color, your normal vector, your roughness value, your metallic value, all those PBR inputs. But Godot then does a stage after that where it loops through all the lights in your scene and actually lights the pixel based on the color information that you supplied. Now you can override the light stage as well, which is very rarely done. Cartoon shaders require that sort of change. But for most other purposes, we purely set colors. Or our base color information of our pixels without any lighting done in our fragment shader. That's where Godot is different from most of the other engines that I've at least worked with. So albedo is an output variable. So in this case, we're saying this is the output of our fragment shader. Here's the base color, the base albedo color that the lighting stage then needs to use to actually light our pixel. We also have a variable here. All the red variables like this are built-in variables. UV, which is an input variable. So we have UV mapping on our object. So every vertex on our object has a UV coordinate. The render engine will, or the GPU will interpolate those UV values from one vertex to another as it draws all the fragments, and we get that value for this particular fragment here, and that allows us to do our texture lookup. Now vertex is special because it's both an input and an output. So vertex coming into our vertex shader is the position of that vertex within our object. And we are expected to output that variable as well, potentially modified if we want to modify it. Now, normally you don't, but if you want to do something like this, where we want to add an extra rotation in, but we want to do it in the shader because that is the place where we can do these sort of things, we do that here. All right. So, that said, because of the type of modification that we're doing, I need to copy our vertex into a variable called v, and that allows us to now apply some calculations. So we're going to do a standard rotation calculation here, and every rotation happens around 1 axis. So from memory, I haven't done this for a while, so I might get it wrong on the first try. We will see. Let's actually do a float. A is. We might do some calculation with that, but that's our angle, which we're just going to do based on our progression of time. And let's just rotate around. So this is going to rotate around a y-axis. I think it's plus. It might be minus. We'll see. If we get it wrong, this is going to be really funky. And it might also be helpful if I actually spell that right. Nope, we're going to do z. And this is the reason why we are first copying vertex into a temporary variable. Because if we didn't do that and we would have changed our x value, then suddenly if we now do our z value, we're not doing it based on the right one. So. And I'm pretty sure one of these needs to be minus instead of plus. We'll see that quickly enough. Let's see if this actually does something. Okay, so we can see that they're rotating, but they're folding in on each other. I'm pretty sure that one of these two should be negative. There we go. So now we can see that we're rotating all of our meshes here, or all our asteroids around around their local z-axis. So you see that they're actually all turning slightly in a different way, but that's because we have given them all random rotations. So we are now rotating our asteroid around our y-axis, and then we're applying the rotation that we've actually saved in our transform. And to be honest, I think that's good enough. I like that. I don't think we should be doing anything more. Now, one thing that we could do is make them all rotate in a different, at a different speed. Maybe. The question then is, what do we drive that on? Well, we could do something crazy. That's a good question. Why would we do that on? We could do it on a position of our asteroid. Which would be coming out of our no, that would be our world matrix. We could try. So this is a bit of a hack, but it might work. So I'm just going to take our X, Y, and Z location of our asteroid. The lighting should be updating, isn't it? I'm not quite sure. Where is our light coming from? It's coming from there. Ah, no, you are absolutely right. And the reason for that is we are not doing the same rotation on our normal. Ah, thanks for that. Let's actually go and move that over there. And now we have to do the exact same change onto our normal. And normal. There we go. Now our lighting should be fixed as well. Thank you for that. I hadn't even noticed that. That's right. Whenever we rotate our object, we also need to make sure that we rotate our normals alongside with this. And if we would be using any type of normal mapping, or we would apply, you know, which we are going to have to add in here, probably need to do that right away, actually, just to prepare for later. Let's actually do that. Now it's going to go double tangent and binormal. So let's do our binormal first. And this is very important. Whenever you rotate your vertex, you also need to rotate all the other guys. And tangents. And this does not matter right now because we are only applying an albedo texture. But once we start doing normal textures and our roughness texture and all that sort of thing, we have to make sure that our binormal and tangents are rotating along with our normals. So there we go. Now we are rotating all the parts that we need to have our lighting working correctly. Okay, so now for a hack. So we're going to multiply our time with a factor based on the position of our asteroid. So I'm just taking the X, Y, and Z position. Our world matrix is the matrix that we are placing it in the world with. Then the first array layer of our world matrix or structure layer is whether it's our X, Y, Z, or origin. And then so it's our x, y, z of our bases and our origin. So 3 is origin, and then it's the x, y, and z of the origin that we are now adding together, just to get a value that is different for every one of our asteroid. Now we can't just do time speed. This will go crazy. There you go. Goes very crazy. We need to apply a modulus to this. Now I think let's apply a modulus of 0.5, and then we should add 0.5 to this. Maybe. Let's see if that works. Okay, so is that a function? It is. Does that work? There we go. All right. There we go. Now all our asteroids are rotating at a different speed. I think I want to make that a bit higher so that it has a bit more difference in speeds between these. So some of them are slower, like this one's very slow, that one's very fast. Yeah, that'll do. Might actually divide that a bit so that we get a little bit more spread. So yeah, you can see that one goes fast, the one next to it goes slow. That's a kind of nice little trick to do that. All right, and again, you know, right now the nice thing about this approach is we're still using our multi-mesh. We're still batch rendering all our asteroids. Okay, we're doing it in small groups right now, like I said before, just for testing right now. We have 60, 70 asteroids in a single multi-mesh. But ideally, when we really want to have a larger asteroid field, we might put 500 or 1,000 in a single multi-mesh, and then have maybe 20, 30 multi-meshes spread around to create quite a large asteroid field. And they're still drawn in batches, but now they are animated. And we're just doing that in our Vertex, which means it all happens on the GPU. It doesn't cost any, there's no buffers being updated and exchange between the CPU and GPU. It's all happening on the GPU, and there we go. So now obviously the last thing that I want to do, now that we've got all those in there, is I want to make sure that all our asteroids are using that shader. And for that, we're just going to go in here. And we go into here, and we're going to go and load our shader in. There we go. So that applies it here. And now all of a sudden, all our asteroids are rotating, which does mean that over here, that already works correctly. Okay, don't have to worry about that. And now all our asteroids are tumbling. And they're all tumbling at different speeds because we're using the world position of each individual asteroid as communicated through the multi-mesh to determine the speed at which it needs to turn. So there we go. We have some tumbling asteroids. So let's do one last little flyby and see how that looks inside of the game. There we go. And then I'm going to go call it a night. This is the other thing that we need to do. Make sure that we don't keep ending up outside of our fighter plane. Alrighty, here we go. Let's go. Cool. That is actually pretty damn impressive. Yeah, you got a lot of asteroids to fly around. All right. Is our planet still there? Our planet's still there as well. Very cool. See if we can come in for a bit of a landing. I got my nose too much down. Oh. All right. Nobody ever wants to fly with me because I am not a very good pilot. There we go. So this I remember from Elite Dangerous, which where you also have this amount of freedom in flight, but then you have your HUD to strafe and go up and down. So that might be something worth implementing at some point as well. All right. I think that is some good progress for tonight. Oh, thanks, Aegean. Remy, our project manager. Good to hear that 3.2.2 is officially out right now, because that contains a few fixes that we needed in this. So that's really cool. Alrighty. Very cool. Ask some questions if you guys have. I'll keep reading chat for another couple of minutes before we call it a day. Fortunately, everything is always a little bit delayed, which is annoying, but it is what it is. That reminds me. Anybody who wants to comment on this, I'm streaming right now on YouTube, and that is because I've always had my YouTube channel. I've always put my tutorials on there, and I'll keep making tutorials for Godot. I'm nearly finished with part 8 of my weapons tutorial. But the question that I have to you guys, something to leave in the comments, should I actually be streaming on Twitch? That's one of the questions that I have. I've only recently started streaming, so I'm not really that in the know of things. YouTube was just a choice of convenience. So if people have good reasons that I should stay with YouTube, or good reasons, like what would it be better to be on Twitch? Also, would you guys follow me if I would move over to Twitch as far as my live streams are concerned? I do plan to do this now every Friday. Every Friday I am going to be working on this project. Obviously, I will probably do more live streams when the possibility arrives. It's almost my kids' holiday, so they can go either way. We've got school holidays in about a week's time. Could be that I have no time and I need to take my kids everywhere, or it could mean that as a result, the schoolwork goes down and I don't have to help them at school that much. We'll see. But I'll probably be doing some ad hoc live streams, just covering whatever I'm working on tutorials, or maybe if someone has a request to know about something, I might spend some time on that. I don't know. It all depends on how much free time I have. But my Fridays, I am trying to keep this going, and I just want to see how far we can get with this little project and turn it into a full game. Now, at this point in time, because of the assets that I'm using, I do not have the source code for this publicly available. Obviously, anybody following along can see how the code is structured, and I am looking into a way to share the code of this without running into trouble with the assets that I'm using. So I might do at some point in time an access to the source code only, without all the models and stuff like that. I don't know. This is still things I'm trying to work out, and might do it as a Patreon reward for my higher patrons. I'm not sure yet. It's still something that's up in the air. This whole project stands completely to the side of the tutorials that I do. So I'm going to keep doing the tutorials. The tutorials are they will stay free. I'll keep uploading the source code to all the tutorials. So that doesn't change. This is just something new that I'm trying. For me, YouTube is the thing that I really like about YouTube is everybody's already on my YouTube channel. Everybody's already subscribed to me, automatically gets notifications. While if I suddenly move to Twitch, you need to get notifications for that. Obviously, I do everything on Twitter as well. Twitter is my main way of communicating with people. That's always the best way to reach me, actually. If you want to reach me, way more efficient to send me a message or a ping or a DM on Twitter, because that's where I'm the most active. Email, I just get way too much email, so things get lost. and I do try to read my comments on YouTube, on my YouTube videos. My biggest problem that I've actually found is that people keep commenting on very old videos that I do because they're still very popular for a good reason. You know, the information doesn't change. It's still as valid today as, you know, a year ago when I made some of these tutorials. But YouTube, even if you have a brand new comment on an old video, it's way down the list of comments. They're sorted based on the age of the video, not on the age of the comments, which is really, really annoying. And I don't know how that translates to my live streams. One thing that I've noticed is that if you go and watch a live stream as, you know, someone else, you will see the chat replay. If I rewatch one of my live streams, I can't find the chats for some reason. Not quite sure about that. I still, you know, I'm still new to this, so. Yeah, so some of the asteroids were flattened because I put that minimum maximum scale. So the minimum scale is 0.5 and the maximum is 4. But we're scaling on, you know, we're doing the random on individual axes. So if the random on the X is small, while the random value that comes on the Y and Z scale is large, you get those pancake asteroids. So if I play with these some more, and let's actually go to our asteroids 1. So if let's say that I make this 2, 2, 2, then you see that now I no longer have really flat ones. I think that scaling there's not enough difference in there, but maybe half is a little bit too much. And now you still have a few really flat ones in there, so maybe I should leave it to that. So we still have a slightly flat one. So this one will probably have 2 in the y-axis and around 4 for all the other axes. But that's kind of okay. So it's a matter of playing around with the minimum scale and maximum scale. It is one of the reasons why I'm wondering, should I be scaling them individually on the axes, or should we just have a minimum scale and maximum scale value and scale all the axes with whatever random value we come up with? I might come back on that. I might change that. Yeah, again, I don't have a whole bunch of experience with Twitch. I follow 1 or 2 Twitch streamers, which are personal friends of mine. So that's really the reason why I'm watching their streams. Also, me being in Australia, I have to say it's really annoying that most people stream when I'm at work, because that's nighttime for them. It's daytime for me. So I don't do a lot of Twitch. So I've heard about, you know, I've seen the raids and don't really get the whole raid thing. And I think that's one of my biggest problems that I have with. I like the simplicity of streaming on YouTube, but I miss the controls that Twitch seems to have. So that's why I'm still weighing them up, and I'm sort of wondering, like, which one would be best for this. Not to mention that, you know, people on YouTube look for small videos. You know, the audience on YouTube are people who are looking for things that they can watch, you know, pause when they need to get some information, or, you know, watch cat videos if they want to watch cat videos. But it's, you know, it's a different audience than from people who watch streamers, where, you know, just like you guys right now, you know, we've gone on for 2 hours. You know, you have to have 2 hours free in your day, and people who generally do that, they're generally on Twitch. So that's the way off that I'm trying to make. I have to admit, because I'm familiar with YouTube, that's why I started streaming on YouTube. That's why I chose it. And potentially that's also the reason why I'm just going to stick with YouTube, because I'm just familiar with it. But yeah, I'm not sure what is the best choice here. That's why I'm asking. Yeah, I'm in Australia. I'm not actually an Aussie. I'm an imported Aussie. I'm originally from the Netherlands, but I have been living in Australia for the last 12 years. So, yes, Aussie. Yeah, Japan's pretty cool too. I hope to visit Japan one of these days. So yeah. Yeah, it's midnight. What is it right now? 12:17. So I tried to do a 2-hour stream. I might actually see if I can do a 9 to 12 stream instead of a 10 to 12. Again, I'm trying to find what works. So the biggest problem that I have is my kids. The reason why I chose 10 is my kids go to bed before 10 o'clock. So everybody's sleeping. I'm still awake. It works. If I start streaming earlier, you have a good chance that my kids suddenly run in or need things or stuff like that. So it would be a bit interruption. But I might try and make it 9 or 9:30. I'm not sure. Still something I'm playing around with. Yeah, so when you look at and there's also someone who asked on one of the live streams that I did whether I can put timestamps on my live streams, and my biggest problem at this point in time is that I just don't have the time to do that. And that's the same thing. That's actually one of the reasons I started live streaming this particular project is looking at, for instance, my weapons tutorial. It took me nearly 2 weeks of working a couple of hours every day to prepare the project and then capture all the footage and then edit and do a proper voiceover so that you don't hear me go all the time, which yes, it's the natural way that I speak, unfortunately. But yeah, there's a lot of time that goes into creating a proper tutorial video, and I really want to do that on the subjects that I'm already working on because they already cost a lot of time. I'm doing this all in my spare time. This is not my job, not yet anyway. So I kind of like something like this where I really actually want to create something. I like the fact that I can use a live stream to both create it and bring people on a journey and teach you guys some things. There's quite a lot of things that we covered in these last 2 hours. And they're not things that I would generally put in a tutorial because it's like the rotating of the asteroids here. It's a neat trick, but it's very hard to turn that into a tutorial. It's so niche and so specific to what we're doing here. Or an open discussion like we just had about how does culling work and why am I distributing this into multiple multi-meshes instead of just plunking one in and putting all the asteroids into a multi-mesh. They fit a live stream much better, and they're hard to cut down into tutorials. Sydney. I am Sydney based. Let's see what else is there. By the way, for everybody here who is in Australia, I haven't done much with it because of the whole pandemic thing. Let's see, Facebook, Godot. Oh, it's Godot. Try it out. Need to be a little bit careful about what I go here. All right, I will look that up later on. But I started about half a year ago. Well, earlier this year, after discussing with Aiken and John that I wanted to do this for ages, just never got around to do it. But I started a Facebook page on for Australian Godot developers. It's pretty quiet at the moment because there's only a handful of people on there, and because of the global pandemic, we haven't really been able to organize anything. But it is something, because there's quite a number of people using Godot in Australia. But I don't think many of us know of each other that we're in Australia and that we're working with this. So one of the things that I'm hoping is to eventually, when this pandemic is past, is start organizing some meetups. Maybe first with the people who are here in Sydney, but we might eventually be able to do something either online or just to get some of the Sydney Godot users together and know that there's some people that we can talk to and that we can help each other and stuff like that. So, and it's pretty cool that there's actually a few in my live streams right now. And yeah, it is when this is something you do in your spare time and you have a day job, especially after working for 8 hours, you don't always have energy to then spend a whole bunch of extra stuff. It's hard, but it's fun. That's the only way that you can get a hobby like this going, I guess. Yeah, I agree. Facebook is. Give me a better alternative, and I will move the group to a better alternative. But right now, the Facebook is a necessary evil, I guess. If it wasn't for the fact that I am Dutch and that I moved down to Australia, and Facebook is just about the only way that I can still keep in touch with people that I know back home, I probably wouldn't even be on Facebook. That's really the only reason that I am still there and I'm hanging out. Obviously, we have the Godot Facebook page is really large, so hanging out there and helping people there is a lot of fun and is worth being there. But Facebook itself, they have made some questionable choices lately. Let's say it that way. Discord is really nice as a place to chat. I don't think that is really a good place to organize a community and organize meetups and stuff like that. Correct me if I'm wrong, but I don't think Discord really has the right tools for that. Yeah, no, I actually I have a Patreon community on Discord, so if you become my patron, you guys can talk to me on Discord there. Of course, I'm also on the Godot Discord. Actually, I've moved away from using IRC mostly to using Discord because I've been using Matrix and Riot to stay in touch with the people through the Godot people on the Godot IRC channels, but it's really been fighting with me lately, and because the #XR channel on the Godot Discord is basically where everybody is right now who is doing VR stuff in Godot. That's really the only place that I hang out to chat to people directly. But again, as far as a community group is concerned, to organize people together, I kind of like the Facebook approach there a little bit more because it does gear you. I'd be using Meetup probably if Meetup didn't cost a whole bunch of money. Yeah, I do program for my day job. I develop accounting and job management software in my spare time, or even spare time during my day job. Yeah, I'm one of those people who, when I was young, I was into games. When I got into the demo scene when I was in my teens. Almost got into game development at that point in time. A lot of my friends ended up at big game studios in Holland. But by chance, when I finished school, I needed a job, and I walked into a company that made software in the telecom industry, and that was a booming industry back in those days. So that was a really good career starter, and I stayed in that, and I still work in tools that I got proficient in back in those days. I just I changed jobs. I got the ability to work here in Australia as a result. So game development has always been a hobby. It's just something that I've always done in my spare time. Ever since VR came around, it's become a little bit more than a hobby. So who knows what the future holds. When you look at questions, and indeed the answers to the questions going away, whether it is on Discord or whether it's actually on almost any platform nowadays, I'm of the opinion that actually doesn't matter. I know that there's a lot of people who get annoyed when someone new comes around and asks a question that has been asked, dozens of times ago already. And while for some questions that is true, where you sort of go like, I know that you knew, but do a 5-second Google search and you would have the answer. Please don't reiterate the same question. For a lot of other questions, I think that asking them on a live community, even if that live community has answered that question before, makes a lot more sense. Once you start searching for answers of those questions, you look at, you do a search right now on Google on reacting to the window size change in Godot. So when I have my Godot game open and I resize the window, if I want to react on that, if I Google on that question, how do I react on the resize of the window? I get different answers depending on the page that I hit is about Godot 2 or Godot 3 or Godot whichever version, because it's changed a few times over time. And before me as a newbie would figure out which of those answers is actually the one that I want, if I ask that question on Discord or Facebook or RSC and I've had the answer given to me in a minute because there's people online, what's the harm? That's how you build a community, by helping each other. So yeah, while there are certain things where I'm sort of going like, go have a look at the the Godot docs, because they're actually quite good nowadays. Sure, but yeah, I don't really mind that there is no search history on a Discord or on IRC or anything like that, because 9 out of 10 times, even if you find the answer, it's questionable whether that's usable, because it's outdated. Artificial intelligence, will it take it us all? Yeah, we are going to succumb to our artificial intelligent overlords, probably in about 1,000 years. Well, a mechanical engineer is useful too. Yeah, it's a matter of learning a language and then putting yourself out there, I guess. Well, that's the other thing. Yeah, when people who were once newbies and now they've learned, and they can help the new group. And again, it's all about the social interaction. It's all about community building. The more people who are willing to take the time out of their day to help someone else, and in a way pay back other people helping them. It's a form of pay it forward. I actually kind of like that about our community, about that everybody tends to be helpful and not get too frustrated if a new person asks a question that we've already seen 100 times. Obviously if that person just becomes really lazy and just asks any stupid question without even trying, yeah, okay, but those are the exception. Most people actually, they've got a goal, they want to build a game, so they don't want to be stuck on some stupid question just while they can ask it on a group and then they can move on, and before you know it, they have a prototype of the game working. So yeah, it's so cool. Yeah, we don't have a junior or senior ranking system. I wonder, I don't have a good example of a community that has made that work. Or whether, something like Facebook or Discord or IRC has support for that. It could work, one of the things that I found very interesting is that I've noticed that on Discord, when people don't get a answer on one of the groups, they'll start private messaging people, especially the ones who are in the moderator or in the, because you do have the higher tiers in Discord. I don't like that part of it. We're not hired to be a help desk. Okay, yeah, it's 12:30, way past bedtime, I think, at least for me. I'm not as young as I used to be and pulling all-nighters. So yeah, guys, I hope you really enjoyed tonight's stream. We've made quite a bit of progress, I think. You know, we've got a little bit more to do on our asteroids, so probably next week we're going to start looking at building the logic to have our collision objects added to our game as we're getting close enough to a group of asteroids. I might see if I have some time during the week to actually dress up this a little bit more, and instead of having 4 groups of asteroids, actually having a properly sized asteroid belt in our game. I'll also have a look at the 3 asteroid meshes from Union Bytes and putting those in there so that we have a little bit of variation in our asteroids. So those things I probably will do during the week, so that next week we can actually hit the ground running, add the logic to get collision shapes in here so that we can actually collide with our asteroids again, like I said before. And maybe that's a good reason to make the asteroids even slightly bigger than they are right now, but I'm going to use static bodies for them, so the asteroids you won't be able to push an asteroid out of the way, but you will be able to hit and bounce off an asteroid, and at some point we'll make sure that we can take damage where you do that. But that's probably a little further. All right. The other thing, obviously, that I really want to get into is starting to add some weapons to our little interceptor, so that we can actually shoot some stuff. Because then we really start moving towards being able to put a level together and actually put some goals in there. The other thing which I'm looking forward to doing, because that is actually something new for me, is to look at enemy ships. So we'll start off very simple and make some really straightforward AI, really dumb AI. When you get close enough to an enemy, they start flying towards you, shooting at you or something like that. But making a proper AI for an enemy ship that actually is interesting to fight in a dogfight, I've got some learning to do there. So I hope you guys enjoy being on that journey with me. So yeah. Oh, hey Daniel, how you going? So good night, everybody, and I will see you all next week.